What if buildings could heal their own cracks? What if bridges, worn down by time and weather, could repair themselves before they ever collapsed? What if the screen on your smartphone, after a fall, just smoothed itself out like nothing happened? This isn't the distant future. It's not science fiction. This is the very real, very present world of self-healing materials. An astonishing convergence of chemistry, engineering, and biomimicry that may soon redefine how we build, live, and interact with the physical world around us. To grasp the brilliance of self-healing materials, we first have to understand the fundamental issue they solve. Everything humans create, from highways to airplanes to microchips, degrades over time. Stress, fatigue, impact, and exposure to the elements create microscopic damage that eventually becomes catastrophic. But in nature, damage doesn't always mean doom. Our skin heals. Bones regenerate. Plants seal wounds. Nature doesn't replace, it restores. And engineers have long asked, why can't our materials do the same? So the race began, to create materials that could autonomously detect damage and initiate repair, without human intervention. The earliest breakthroughs were in polymers, materials that form the basis of plastics and rubbers. Scientists engineered polymers that contain tiny capsules or channels filled with healing agents. When a crack forms, these capsules rupture, releasing a liquid that reacts with the surrounding material to seal the break. Think of it as the material's version of clotting blood, an instant, automatic response to trauma. But that was just the beginning. Researchers soon moved beyond simple patchwork repairs. They started developing vascular systems, networks of microchannels inside the material that mimic blood vessels. These channels carry healing chemicals to damaged areas continuously, enabling the material to heal multiple times, not just once. These aren't just passive materials anymore, they're alive with functionality. In some cases, the materials can even sense the damage. Certain engineered polymers change color when stressed or cracked. Others generate tiny electrical signals that alert a monitoring system. This combination of healing and self-awareness moves us closer to materials that are not only resilient but responsive, capable of diagnostics, prevention, and even adaptation. Take concrete, for example. One of the most widely used and structurally critical materials on Earth. It cracks, always. And those cracks allow in water, which freezes, expands, and worsens the problem. Eventually, this leads to corrosion of steel reinforcement, structural failure, and massive repair costs. Enter self-healing concrete, a material infused with bacteria. These bacteria lie dormant in the concrete, sometimes for years. But when water enters a crack, the bacteria wake up, feed on nutrients also embedded in the concrete, and produce limestone, literally sealing the crack from the inside out. No chemicals, no machinery, just biology doing its work quietly inside your infrastructure. And then there's metal. Creating self-healing metals is vastly more difficult, because metals don't flow or shift like polymers. But research is underway into shape memory alloys, metals that can return to a predefined shape when heated. These can heal dents or warps caused by mechanical stress. Others explore embedding microcapsules into protective metal coatings, so if corrosion starts, the healing agent gets released and restores the surface layer before the metal is compromised. Even electronics are getting a taste of this revolution. Imagine flexible circuits that self-repair after being stretched or torn. Researchers have already developed conductive gels and stretchable materials that can restore their electrical pathways when damaged, making self-healing wearable tech, smart textiles, and even robotic skin a very real possibility. The automotive industry is already exploring self-healing paints. You scratch your car, leave it in the sun, and hours later, the scratch fades. That's because some paints incorporate polymers that reconfigure themselves when exposed to heat. They don't eliminate damage entirely, but they reduce visibility, slow degradation, and extend longevity without any human effort. In aerospace, where even tiny cracks can be catastrophic, self-healing composites are being developed to improve aircraft safety and reduce maintenance. These composites can patch themselves mid-flight, buying critical time, preventing failure, and alerting pilots or systems to the issue as it happens. But the engineering behind these materials isn't just about magic capsules and chemistry tricks. It's about designing for failure as a feature, a total shift from traditional thinking. For centuries, materials were made to resist failure. Now, they're being made to embrace it and recover from it. That philosophical shift opens the door to smarter cities, longer-lasting machines, and a more sustainable world. Self-healing materials also dovetail perfectly with the principles of sustainability. If structures can repair themselves, we reduce waste, lower carbon emissions, and prolong the life cycle of buildings and machines. This could dramatically change the economics of construction and maintenance, particularly in remote or hazardous environments, where manual repair is dangerous or impossible. Take space travel. On a space station or a Mars base, every repair counts. Engineers are designing self-healing materials for spacecraft hulls, which could automatically seal micrometeoroid punctures or radiation-induced damage. That means fewer tools, fewer risks, and greater autonomy for long-duration missions. The same concepts could apply underwater, in nuclear reactors, or inside your own home. The future of self-healing materials may lie in combining them with AI. Imagine infrastructure that not only heals but learns. Buildings with embedded neural networks that adapt their internal structure based on patterns of stress. Roads that detect traffic wear, communicate with smart vehicles, and reinforce themselves in high-impact zones. Clothing that adjusts to temperature, movement, and wear patterns, repairing itself overnight. These possibilities are no longer blue-sky dreams. They're being tested in labs and prototypes right now. It's not a question of if they'll arrive. It's a question of how soon we can scale them up, lower costs, and integrate them into everyday products. But perhaps the most profound part of this story isn't the science. It's the shift in how we relate to what we build. We are stepping into an era where our materials are not static objects, but living systems. They don't just exist, they evolve, interact, and respond. It's a future where the line between biology and engineering blurs. Where walls breathe, cars heal, and roads think. It's the dawn of materials that take care of themselves, and by extension, take care of us. That's not just innovation, that's transformation. If this look into the cutting-edge world of self-healing materials opened your eyes, then keep following us for more. Subscribe to the channel, hit that like button, and share this video with someone who loves science and engineering. The age of reactive materials is ending. The age of regenerative design is here, and it's only just beginning.